Jim Malos again. We're kind of piecing these together. We're learning a lot about how to do this stuff. I'm getting some great help, guys. Otherwise, I wouldn't be able to present. I would not be able to present any of this to you guys if I wasn't getting the great help that I'm getting. So this is very important stuff. I'm getting some great help here. So we got some very dedicated people working for us and doing the job. So let's keep going as we proceed with this whole process. I am going to try to go relatively quickly and finish. Leave this just for the bookkeeping that we're doing, you guys. I'm going to try to finish, the old. Let me see here, guys. I'm going to try to. Old practice exam number 1. This is hopefully the last part of this that we're doing. So we go at a pretty decent clip, guys, and get you through this stuff. Again, it's presumed you always got other resources to look at, and hopefully what I'm doing augments those resources pretty well. Old practice exam number 1. Hopefully this is the final leg on this thing. Let's see what kind of endurance I got on the whole process, I guess, and let's get through it. You saw me recently, very recently. Again, we're probably going to bunch these together a little bit, or we may keep them a little bit separately. We'll see how they're going to go. Let's see how the people that are helping me choose to do this. But you saw me do things with exponents. Now let's talk about scientific notation. For that old practice exam number 1. For scientific notation, see how it writes here, guys. You see that pretty well? Looks like it's pretty legible for everybody. All right. Write scientific notation. You want to have a number that is between 1 and 10, not including 10, as the lead number. And the rest is exponentiation. So what number, how can I construct a number between 1 and 10, not including 10? How about 3.3? How far would you move the decimal point over from 3.3 to go 1, 2, 3, 4, 5, 6, 7? You move 7 over, that's the same as multiplying that by 10 million. If you multiply by 10 million, you're multiplying by 10 to the 7th. So this is that. On the flip side of that, they might say to you, well, let's say if I didn't give you this, let's say it was a problem like number 33, and they said, .874 times 10 to the negative 6, 2, 8, 7, 4. Take a walk of negative 6. Negative 1, 2, 3, 4, 5, 6. You always start from the decimal point and run as many places they're asking you to run. There are some other problems in here that are that are frankly, in my opinion, not too good. There's some other stuff that is very good, but there's a few problems here that aren't the greatest for us. So let me try to look here and make some sense out of something that might work for us pretty well. Look at problem number 35. Let me just run down how to do these problems, guys. I think it's your best bet, and you can always be reading the book, and then hopefully this augments a lot of what's going on there. So I got to finish this, help you guys out, and we'll take it from there. They are saying, what if you got this? Again, they did something here. I don't know a good way to say it. This is just a poor selection of problems. A couple of them are poor selection of problems, and these are that happens. I mean, that can happen to anybody. I've made up problems that have not been the best, and on occasion, The overwhelming majority of the problems that are here are very good. A couple of the problems are not good. They're not really applicable. So I'm gonna have to make something up to make it work. Let me just make one up here, guys. Whereas the other problems are excellent. Don't get me wrong on that. I mean, just some are not, and just a very few. The overwhelming majority are quite good, but the try to think here. Go like this. Let me just. Requires a little bit of a change here. I think we're fine. If this is the problem here, and they want you to solve for y, how are you going to do it? Well, there's a lot you can do. I mean, minus 2 is plus a negative 2. Go here, go there. Y is the same as 1y. Go here, go there. This is 5y. 5 times negative 2 is negative 10. Here's 1y. 3 times 4 is 12. 3 times 3y is 9y. (6y) plus negative 10 equals 12 plus 9y. Tell you what I'm going to do. Let me subtract the 6y on each side and add a negative 12 on each side. So, forgive me here. So let me, forgive me again, I'll do it one more time here, guys. I will, let's just make sure I did this right. Okay, let me add a negative 12 on each side. I get to that. Let me add a negative 6y on each side. And I got that. Divide by 3 on each side. And there's your answer. This can be written a whole bunch of ways. This can be written as negative 7 and 1/3. That also works. They don't specify. If I'm grading something by hand, I don't care one way or the other, et cetera, et cetera. That's what calculators are for, I guess, right? I mean, some of these can, with a calculator, can be done quite well. So on and so forth. Okay, so what if I gave you that as a problem? Solve for W. You're going to hear me say this many times. Those of you who know me from the past know I do this all the time. There are many ways to solve problems like this. There's always going to be many ways to solve these problems. Nobody cares how you go about, usually, I mean, I'll speak for myself. I don't care how you solve a problem short of cheating. If you don't cheat, if you work hard, and whatever approach you use and you are getting the right answer, you're fine. You're fine. I'll tell you what, for me, the easiest thing to do is get rid of all the stuff that's underneath, the 4 and the 10. One of the best ways to get rid of the 4 and the 10 that are present there is to multiply by 40 on each side. So if you took if two things are equal, they remain equal if you do the same thing on each side. I'll multiply by 40 on each side. Forty is the same as 40 over 1. That's 7W over 4. 40 over 1 is the same as 40 times 1. Over 1. Look, I'm just multiplying by the same thing on each side. Okay? So 4 goes into 40 10 times. 10 goes into 40 4 times. Let's go. Let's see what we got here. Way over there, 10 times 7w. 10 times 7w is 70w. 1 times 1 is 1 on the bottom. 70w divided by 1 is 70w. 40 times 1 is 40. Cancellation here, 4 times 9w. 4 times 9w is that. 40 times 3 is 120. Let's keep going. Let's subtract 36w on each side. Let's subtract 40 on each side. Let's divide by 34 on each side. I don't know, let's reduce a bit, I guess. 2 goes into here 17 times. 2 goes into here 40 times. 40 times 2, 17 times 2. Etc., etc. That's 2 and 6/17. 2 and 6/17. There's a decimal approximation that you could arrive at some point. It's neither here nor there. Know the process, you guys. This is the process that we're doing. We know how to do it. There are some good problems here that come along the pass, I guess you could say. Let me try to debate with myself how I want to go here, how I want to do some of this stuff. It can get a little rough. Luckily, we're gonna, like I said, you're gonna have this on tape, and you can always go back and look at it. So I think it's gonna work out pretty good for us in that regard. Let me kind of pace myself how I want to do this. I'm not gonna worry. They ask you to solve certain problems. They want you to use interval notation, graphing notation, some other notation. That's not the biggest deal in the world right now for us. If you know how to solve something, that's kind of the big thing. How you actually, I mean, I'll see exactly how they want to do some of the stuff here, guys. There's a certain format that's been implemented. I've been gone for a little while, and I'm back doing some stuff. I've had other teaching commitments, at least regarding the MATC commitments I had. I wasn't at MATC for a while, so but had a lot of work at UWM. It's been a great experience in both places, you guys. So exactly how they're going to run this, I'm going to find out a little bit more after the taping of all this. But for our purposes, the math is the math. Right now, let's just know how to do the math. Let's have the gut feeling to, hey, one way or the other, I can give people a strong answer that is that answers the question, a good answer, regardless of what format people want it reported. Do I know what I'm doing, and can I give the right answer? And that's kind of how I'm going right now, and more to come in the future when we talk about this stuff. Okay, so we're looking pretty good right here, guys. There are, trying to think here. I don't know if I need to do all these. I do a couple of these. Let me do 38 and 39. 40 is just like that. 40 is just like 38 and 39. So let me just see what I can do. Let me go with 38 before I start erasing all this stuff, you guys. Problem 38, they're saying the absolute value of some quantity plus 7. The absolute value of 3x plus 7 plus 2 will give me 11. Okay, let's be careful. I'll tell you what I'm going to do. I guess there's an easy way, and I guess there's an easy way. Everything is easy for us, for me, for you, for everybody, if we know what we're doing. We feel good about it. So we're going to learn how to do this stuff. We're going to feel okay. Absolute value has an attribute. Here's one attribute. The absolute value of anything greater than or equal to 0 is the quantity. And the absolute value of anything less than 0 is the opposite of that quantity. In other words, if I wanted to say to you, I mean, maybe maybe sooner or later we got to say something, guys. So maybe I'll say it now. If I were to say to you, the absolute value of x is equal to 5. Let's just keep this in here. We're going to do this one, guys, in a second. Before we go there, let's talk a little bit and get some of this stuff out of our circuit. The absolute value of x equal to 5. When does that happen? We all know that the absolute value of negative 5, you put a negative 5 right here, the absolute value of negative 5 is 5. If you put a positive 5 right here, it works also. So it's this or that. That works. What if somebody said this? Absolute value of x is less than 5. Go back here. These are the two goalposts. These are the two end zones, so to speak. Here's a negative 5. Here's a positive 5. All numbers. Look, if x was equal to a negative 10, the absolute value of negative 10. This was a negative 10. The absolute value of negative 10 is 10. 10 is a lot less than 5. You gotta be sandwiched between the solution pertaining to the equation. Sandwiched between the solution pertaining to the equation. Pretty fascinating stuff. It's that. This is an and statement. This is an and statement. It's x is greater than negative 5 and x is less than 5. This is the mathematical and statement. A mathematical and statement means there's constraint. The and statement can also be written like this. Intersection. This intersection thing means and. And intersection mean the same thing. The mathematical and means constraint. You have to have a GPA of 3.5 and be from the state of Wisconsin to attend this. You have to be a legal resident of the state of Wisconsin and have a GPA of 3.5 in order to be part of that club. Really, and. It's not enough to have one or the other, it's both. And constrains. And is constraining. Okay? So there's a lot of ways you can write this stuff. I'm going to answer this stuff to the best of my ability, and I think you guys are going to be okay with this. But that's where this thing came from. Tell you what I'm going to do. What if it wasn't less than? What if it was greater than? That's an or statement. X could be greater than 5, or X could be less than negative 5. Really? Sure. How about a negative 10? A negative 10 is less than negative 5. A negative 10 is less than negative 5, but the absolute value of negative 10 is bigger than 5. Negative 10 is less than negative 5, but the absolute value of negative 10 is 10. Look at that. This is an or statement. It would be this. Union means or. Union. That intersection means and. Union means or. And that's some pretty fascinating stuff. It helps us do a lot of the problems that you want to do. The X doesn't have to be an X. The X could be a whole bunch of stuff. You could have 3x minus 9 is equal to 5. What does that mean? Guys, based on what I've done, your new x is this guy. Here's your new x. 3x minus 9 is the new x. What does that mean? Well, here it means 3x minus 9 equals 5, or 3x minus 9 equals a negative 5. What did I say here? X was equal to negative 5 or x was equal to 5? Here, this is your new x. This is your new x. He can be 5 or he can be negative 5. This guy could be equal to 5 or this guy could be equal to negative 5. Add 9 on each side and divide by 3. Here's one answer. Add 9 on each side and divide by 3. 9 here, that's 4. You can see that. I'm sorry, I know I get it, guys. About 10 minutes ago, I wrote this up here. I promise you I'm going to do it, and then I'm going to do a whole lot more with it. We're going to do a whole lot more. But there's your answer. Pretty interesting. See what I got. Well, you saw the arguments. You saw what we're doing. After we do that, if we expand on this a little bit, it should be a pretty easy move to make. And we got this in mind. We're going to take care of this. Not forgetting it. It's going to be easy for us. We already kind of took care of it right here. Here you go. There's your answer on that one. What if it was this? Might as well use the same guys in there. Let's make it less than 5. I just told you this is your new x. There's your new x. What's it going to be? It's going to be 3x minus 9 is, let's see here. Let's find out. I mean, it's going to be, 3x minus 9 is going to be greater than negative 5. And it's going to be less than 5. The 3x minus 9 is going to be here, and and x is less than 14/3. You're graphing that. Here's 4/3. Here's 14/3. Everything in between, not including. If it's greater than or equal to, or less than or equal to, less than or equal to, or greater than or equal to, you darken this. That's all it is. 4/3, 14/3. That's it. That's how you do it. What if they had this? Well, we did this one too. Didn't we say that it was going to be 3x minus 9 is greater than negative, is less than -5, or 3x minus 9 is bigger than 5. Okay? See what we can do here. Let me add 9 on each side, divide by 3. It's starting to sound like a broken record, I guess. Add 9 on each side, divide by 3. So there you go. You got this. What's that all about? So bigger than 4/3, or 4/3 is bigger than x. Everybody over here is what that is. X is bigger than 14/3. That's this. This is the OR statement. Wow, look at this though. There's an x value associated with 14/3 and an x value associated with 4/3. Same thing right here. X value associated with 4/3, x value associated with 14/3, and x value associated with 14/3 and x value associated with 4/3. Once you can solve the equation, the and or statements, this right here is an and statement. This is an or statement. I've seen different ways, there's different ways to solve this. I just showed you algebraically and then graphically. There is interval notation as well. Let me not go there right now. This is enough for now. Know how to do it. Know how to do something like this. This is a big thing. So this is where some of this stuff is coming from, you guys, when we're trying to do all this. So let me, with this having been said, let me erase this. Let's knock out a couple of these. I think it should get us to a lot of where we need to go. In here, let me just. Let me just, what we're talking about is 1994 had a price of X. You multiply by 117. Let me see here. Now we got to be careful. It's a 117% increase. So if you take 117% of X, that's the amount of the increase, and then add X, that will get you the 123,000. So we got 123,000. There was the price in 94, which was X, or 1X. And you'll increase it by 117%, which is 1.7 times X. When you do this, 1X and 1.2, 1X and 1.7X, 1X and 1X and 1.7, I can't even talk, guys, forgive me. 1X plus 1.17X is 2.17X. And you got this. I think we're going in this direction to do it. That's a little, again, you gotta watch the language, guys. You watch how the language is used when they're doing this kind of thing. But it should be coming along those lines. So it should be, I don't know, like 50,000. Who knows what it is? Let's see where it's at. Let's see what I don't have my calculator on me. 56,682. Now, it might be a round off, guys. There might be a round off. You might have a different answer on that, as long as your procedure's right. The 117% increase means you will add. It doesn't mean 1.17 times X only. It means you will add 117% of the original price onto the price of the original. In other words, this thing represents, you know, you want to get to here. You want this. That's the new price. Well, there was an original price, and then you upped it by more than double. I mean, here's the original price, and then you added 117% of X onto that. And that's kind of where they're going here. This is pretty potentially confusing, even if you know a lot of the mathematics, you guys. So kind of watch out how they're talking about that. They get into linear equations a bit and how to solve certain things here on that. So pretty interesting stuff that way. And we could talk about, like later on, I'll talk about functions and relations and stuff like that. But right now, my big thing is I think some of the linear equations, how you'd actually take a look at something like that and kind of leave it at that. And maybe I'll get into some other stuff later. Let's talk. This is the equation y equals some constant times x plus another constant. This is a linear equation in slope-intercept form. They call this the slope. They call this the y-intercept. And we can do a lot of stuff with this. Now, if you're talking about two different lines, you guys, if two lines with different slopes, if one slope has a slope m1 and the other line has a slope m2, if they are equal to each other, then that implies that the lines are parallel to each other. They never get closer to each other. They never get further away from each other anywhere. They are parallel lines, like parallel bars that Olympic gymnasts use. They don't get closer, they don't get further away. They're parallel lines. If you talk about two lines like that. If you take the two slopes, you multiply them and you get -1 for an answer, that implies that they are perpendicular. This is line L1, this is line L2, let's say. This is L2, this is L1. They are perpendicular lines. Not, they could be perpendicular this way. They could be like an X shape that way, or this way, or whatever. But they are perpendicular. If the product of the slopes equals this. How do you find the slope of a line? If you got a line, x1, y1, forgive me, if you have a point, x1, y, if you have a point, x1, y1, and a point, x2, y2, If you have a point x1, y1 and a point x2, y2, and they lie on the same line, let's say this is x1, this is y1, this is x2, this is y2. The slope is this. It's the rise over the run. How do you find it? The slope will be the change in the y's over the change in the x's. It doesn't matter which one you call x1, y1, and which one you call x2, y2, but you got to put them in, well, you got to stay the same. Once you choose an order, you've got to stay with that order that you chose. Delta y over delta x is what the slope is going to be. So, if a line doesn't look like this, it's a good idea to make it look like this. This is, if you were to graph a line like this, you know, and it was doing that, this right here would be 0, comma b. That's the y-intercept. And the slope would be the rise over the run. And that's equal to m. So a lot of this stuff's a little easier done than said. You're going to be reading the book and stuff when you're doing it, but we're going to figure it out. So let me do a few of these and see what we can say here. I'm going to skip a couple, probably hook around and do some stuff with you guys as we need to as the semester progresses. We'll see. We'll see. Right now, I'm kind of in a little bit of a time constraint. We've had things happen that have kind of slowed us down. But man, if I didn't have these people helping me, I wouldn't be able to do any of this. So we're lucky. We're lucky we got everybody on board doing this, man. Because I would not be able to. Certainly by myself, I couldn't do this. You know. So we're doing good. We got a little bit of time constraint going on. But let me get through a few things with you in the next 20 minutes or so, and we'll kind of take it from there. See what we can do. There's a few problems there. I think I just need to get through because I think it's going to help you out a lot if we can do it. You know, find the slope of a line that passes through. Like, let me do something like problem number 55. Let's say it doesn't matter which one you use now. Now remember what we said. If you want to find the slope, it's the change in the y's over the change in the x's. Could you just as easily have put the 1's right here and the 2's right there? Yeah, as long as you do it for both. You got to be really consistent, though. You got to be consistent. If you're going to call one of them x1, y1, and you call the other one x2, y2, you can just as easily go y1 minus y2 over x1 minus x2. It works fine. It doesn't really matter. You got to be consistent, though. The slope is this. They gave you some of the line that they said -4 comma -1. And the other one's 8 comma -9. What does that mean? Plain and simple, y1 is -1, x1 is -4, y2 is -9, x2 is 4. So -9 is y2, -1 is y1, be careful, 8 is x2. Negative 4 is x1. Minus and minus is plus, that's negative 8 at the end of the day. Minus and minus is plus, that's 12. Got to be reduced to lowest terms, guys. Always work under the assumption. Always work under the assumption that you're supposed to do things in negative in lowest terms. The slope of this line is negative 2/3. You know, there's a lot you could say here, man. I mean, let me try to kill a whole bunch of birds with one stone, because I don't have a lot of time, unfortunately, right now. But I mean, we can always come back to it. But this is enough to teach us something, I think, if it can work. Let me just see here. And I'm sure this is not going to write, but well, it does write, actually. All right, we got this. Let's see if that's legible. Okay, you can see it. I'd like to ask you a question. I mean, let's kind of work with this. Let's work with this. What is the equation of the line y equals mx plus b? What is the equation of the line that passes through these 2 points? Tell you what, leave the y alone. That just stays. You got to find m, you got to find b, and you put them in that place, and then you're done. Well, I just found m, guys. I just found m. It's 2/3. That's x plus b. Now let me find the b that'll solve it. You can pick either one of these 2 points and their coordinates. It doesn't matter which one you pick. Either one of those 2 points you can pick. I'll tell you what I'm going to do. I'm going to take the 8 comma. I'm going to take the 8 comma 9. 8 comma negative 9 is x comma y. X equals 8. Y equals negative 9. That's what it means. Here's x, here's y. Plug it in here and solve for b, and you're done. And you're done. Y equals negative 2/3 x plus b. Put negative 9 right here. Put 8 right here. Put b right here. You got negative 9. Let's see what we got here. Negative 2 times 8 is negative 16. Plus b. Add positive 16 over 3 on each side. Is negative 27 divided by 3 the same as negative 9? Is 16 over 3? Get a common denominator. Got to add them. Add them up. Y equals mx plus b. Y equals negative 2/3 x plus negative 11/3. That is the equation of the line. They asked us for the slope. We did them one better. We found the slope. They asked us for the slope. We did them one better. We found the slope, and then we found the y-intercept. The y-intercept was negative 11. Here's the y-intercept. B is a negative 11/3, and the slope is m equals 2/3. And then you just plug that into, find what m is, Put it in there. Find what B is. Put it in there. And you got it. That is the slope of the line that goes through those 2 points. Find me the slope of a line that's parallel to this guy. Hey, the slope of a line parallel to this guy has to have an equal slope. Its slope is also negative 2/3. Find me the slope of a line that's perpendicular to this guy. Perpendicular, huh? For them to be perpendicular, for perpendicular now, what is the we said the product is, when they're equal, that implies parallel. When the product of the 2 slopes is -1, that implies perpendicular. Well, what would you multiply to get -1? How about 3 halves? Not -3. You're not getting the reciprocal. You're getting the negative reciprocal. There it is. That's the slope of the line that's perpendicular to him. Find me. Find me the equation of a line that passes. Let me try to think of one here, guys. Now, if somebody gave you that, okay, that's it. So now, the line perpendicular to him. Find me the equation of a line that's perpendicular to this guy and passes through. I'm making this up now. And let's see what it passes through. Try to think of something good here. Passes through 2, -2. It passes through that point, and it's perpendicular to him. I got to find a line perpendicular to this guy. First things first. The line perpendicular to this guy will be of the form y equals mx plus b. Yes, it will. It will be something with a slope of 3 halves. We already talked about that criteria right here. It's going to be 3 halves. I just got to find b and I'm done. I got to find b and I'm done. Okay, true. I've got to find b. How about it's going through the point? Let's see what we got here. What did you say? We said it was 2, -2. That means x equals, it's going to go, I got to find it going through x equals 2 and x equals, I got to find it going through the point 2, -2, which means x value equals 2, y value equals -2. That's the one. Let's see what I can do. I'll take this guy. Here it is. Here's the bread and butter. We said it was the negative reciprocal. Now, I already discovered this. I discovered the slope of the line and the y-intercept of the line that passes through these 2 points. -4, -1, and 8, -9. I found the slope and y-intercept. Therefore, when I do that, I found the equation of the line. I found the equation of the line that passes through these 2 points. Then I ask you, please find me the equation of the line. Please find me the equation of the line that is perpendicular to this line. Find me the equation of the line that is perpendicular to this line and passes through the point 2, -2. Well, if it's perpendicular to this line, it has a slope which is the negative reciprocal of -2/3. So it's got this slope. That's the slope of the mystery line that's perpendicular to this line. The slope of the mystery line that's perpendicular to this line, the slope of the line that's perpendicular to this line is this. Now we just got to find the y-intercept. The line perpendicular to this line has this slope, and it passes through this point. Well, we've got the slope. I just got to find the b here. We said 2, -2. So y is -2. This guy's 2. Man, let's find out what happens here. The 2's cancel, and you end up getting -2, right? You got -2 here. The 2's cancel. That's 3. Add a -3 on each side. B equals -5. 3 halves. Y equals 3 halves x plus -5. That's the big stuff. That's really, really important stuff when we're doing this, in this whole process, you guys. It's really, really important. At the end of the day here, you know, let's figure out what we just kind of did. That's this line right here. So in this is kind of the crazy stuff about it. If you were to take -4, -1 and 8, -9, if you put -4, -1 right here and grind it out, it works. It's true. If you put 8 and -9 right here, grind it out, it works. So this is the original line. The line that's perpendicular to it, we found that too, and it's this. Very, very important stuff. In essence, you guys, they didn't ask this for number 55. They just asked for the slope. But we're able to do all of those. You know, we're able to do all of those when we do something like that. So it's a lot there. Let me do one more here that I think maybe kind of helps us out. Go to 58 because other stuff we can look at. Yes. So when you look at this, and I might, like I said, I may just do one of these guys because I think I've already shown you how to do it in an example that I made up. And let's do this again. I think it should go pretty smooth. Let's solve for it. Let's subtract 2 on each side. It should be pretty straightforward. I don't need to do it given what I've already done now. I need to go beyond this. Subtract 2 on each side. You get this. The absolute value of this is equal to that. What does it mean? That means this guy right here, that whole thing could be equal to a -9 because the absolute value of -9 would be 9. Or this thing right here could be equal to a +9. The absolute value of 9 is 9. Subtract 7 on each side and divide by 3. Subtract 7. You get -16 here. 3x equals -16. Divide by 3. You got this. Subtract 7 on each side. You get 2. 3x equals 2. X equals 2/3. And there it is. There's some other stuff here they say. Let me kind of look at it. I think if I show you the procedure, you should be fine. And I've shown you, like I said, the way I'm going to show it. Let's just see. Let's see how this all plays out. Let me do problem number 41. F equals AB squared plus ACB. And they want you to solve for A. Solve for A, huh? Gotta get A by itself. You can't play games here, guys. You can't get the A over there. There's things you can do. A lot of ways to go here, but your best bet is factor the A out. Get the A by itself before you actually get it by itself. In plain English, factor the A from the right side. Factor the A from the right side. Divide this quantity into F and you're done. And there it is. So it's very similar processes here for a lot of what's going on here, guys. How to write something when they say this stuff. I think the way I showed you should be pretty good for 43 and 44. There's an or statement there, and it should work about right. How you graph something like this. Let me do it at least to at least have it in our corner here, I guess you could say. X is greater than 1, or X is greater than -3. They want you how to do this. So what happens here is, I wish they would have written this differently, to be honest with you, but that's okay. I mean, I'm fortunate to have this thing, but I would say that if you're looking at how to do this, you'd have this guy right here, you have it 0 right here, here's 1. Greater than or equal to 1 is this. If you're going to graph that, it's this. Or X is greater than -3. Okay, you're probably number 45. How will we solve that? Now we already kind of, like I said, I think we already got ahead of the ball game on this thing to be able to do this problem. We've already done this. I mean, is what I guess what I'm trying to say. If you're looking at it, I think very similar to it. They're saying if you got -1 right here. X minus 3 over 2 less than 4. What's going on here? Anytime they sandwich something in like this, it is an and statement. Anytime something like this guy is sandwiched between two values, it's an and statement. So what you're going to do is you're going to say -1 is less than or equal to 2x minus 3 over 2, and (2x minus 3 over 2) is less than 4. Let's deal with it. Let's multiply by 2 on each side. Let's add 3 on each side. So we're right here. Just deal with this guy. Deal with them one at a time, guys. One at a time. Let's multiply by 2. Let's multiply by 2 on each side. And add 3 on each side. You got this. Divide by 2. Forgive me. Let's see here. We've got 1/2 is less than or equal to x, or x is greater than or equal to 1/2. And let's go for it right here. Let's multiply by 2 on each side. Let's add 3 on each side. Let's divide by 2 on each side. There it is. There it is. And there's, you know, how are we going to graph it? You've seen me graph this stuff in the past. How are you going to do it? This is going to be sandwiched between 2 places. So for this one right here, x is going to be greater than 1/2, but x is going to be smaller than 11/2. So this is greater than or equal to. So this is solid. This is solid. This is 11/2. This is just 1/2. 1/2, 11/2, and everything here. And in interval notation, if it's inclusive, if it's not inclusive, it's parentheses. It's brackets if it is inclusive. And you have that. There's no way to write it. Okay. Here's how, you know, there's more to it than that. The and means you got this, you got this, you've got this, and you've got that. What does that mean? That means 1/2 is less than or equal to x, and x is less than or equal to 11/2. There, there, and there. All 3 are valid. This and statement can be written in this shorthand. Well, that's pretty good. And that's kind of the procedure when you're doing something like that, guys. And it's, you know, 45, 46 are very similar in that regard. They did something similar to what I did earlier. They got 47. This should be pretty, it looks really legible, guys. It looks really nice. So, absolute value of 8x minus 3 greater than or equal to 8. For the record, what the heck? Let's make one up. If it's 8x minus 3, the absolute value of 8x minus 3 less than or equal to 8, that's a different dynamic. What is it? This is an and statement. This is an and statement. If it's this, you'd have to solve this guy. You basically take a -8. Sorry, less than or equal to, greater than or equal to. And, or intersection, whatever. Add a +3 on each side. Add a +3 on each side, -5. Divide by 8. Add a +3 on each side. Divide by 8. Let's sandwich them, guys. So on and so forth. You know how to take it from there. From there, you know how to take it. If they would have presented it like that. This one is different. It's an or statement. Is less than or equal to negative 8, or is greater than or equal to positive 8. Do the algebra. Notice how they solve the exact same way, guys. The algebra, it's like you're solving an equation. Again, the only time this blows up on us is if we multiply or divide by a negative number that we've introduced. Then the direction of the inequality reverses. So watch out for that. Add a 3 on each, add a positive 3 on each side. Add a positive 3 on each side and divide by 8. Adding a positive 3 on each side and dividing by 8. If I was dividing by a negative 8, the direction of the inequality would reverse. You solve it just like you're solving an equation. But if you introduce multiplication or division by a negative number, the direction of the inequality will reverse itself. Add 3 on each side. Divide by 8. Hey, that 11 over 8 and the negative 5 over 8 look awful similar here, huh? That's or union. That's it, you're done. What does that look like? Well, it looks like that going this way. The other guy going this way. This is negative 5/8. This is negative 5/8. This is 11/8. Over here, it's the exact same guys, you guys. Only it's in between the two. Here's the negative 5/8. Here's the 11/8. Here's the 0. The exact same location. If it's an equation, it's these two guys. Get everything else, these guys are kind of the central point. They're still kind of the central point when it's an or statement. They're still kind of the central point when it's an and statement. Here's the and statement, here's the or statement. You put them together, you got the whole number line actually. But here's the and statement sandwiched in when you graph it. Here's the or statement. It goes outward like that. Pretty important to look at. They didn't give in that practice. In the practice, you can see they don't give the and statement. So I wanted to put that in there a little bit. At least I don't see it anywhere. They've got some stuff pertaining to some word problems here that are pretty interesting. And I'll get into line. We'll talk about lines a little bit as well. Okay, we talk about stuff. Let me see what we can do here. Let me get rid of this. There is, if you were to graph a line, you guys. If I said to you, y equals 3x plus 5, you can set up a t-chart, and you can put any 2 points. You can put a 0, you can put a 1, you can put a 2 for x, and they'll spit out the y. So put a 0 right here. That's nothing. That's just 5. So that's x. That's your x comma. That's an x comma y right there. Put a 1 right here. 1 times 3 plus 5. That's 8. Put a 2 right here. 2 times 3 plus 5 is 11. That's x comma y. That's x comma y. That's 0 comma 5. 1 comma 8. 2 comma 11, etc. How would you graph it? Here's 0. Here's x equals 0. 1, 2, 3, 4, 5. Here's 1. 1, 2, 3, 4, 5, 6, 7, 8. Here's 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Notice they lie in a straight line. The slope, the rise over the run, you don't have to put this in the graph, but I just put it in there. Rise over the run is 3. The y-intercept is 0, 5. That's b. It's 0, b. That's the slope. If it would have been a negative 3, well, there's a moral to all these stories, I guess you could say. If it was this, it would play out like this. Here's 0, here's 1, here's 2. It would be, you'd have the 5 right here, and it'd be doing something like this. It'd look just like this guy. It'd be a mirror reflection. This is m equals negative 3. If it's a negative slope, well, let's talk a little bit. If it's a positive slope, it slopes upward to the right. A positive slope slopes upward to the right. A negative slope slopes upward to the left. An undefined slope goes straight up and down, and it's y equals something. Y equals some constant. That's an undefined slope, infinite slope. You don't want to ride your bike on this. It's easier to ride your bike on something like this, and this is when x is a constant. Please forgive me on that one. This is x equals a constant. It's kind of odd. The straight up and down is a constant x. Here, the y is the constant for horizontal. The slope here is equal to 0. Slope is 0 if it's horizontal. It's y equals a constant. Y equals, whatever I think they call it, y equals b, where b is a constant. And x is equal to x equals a. I think the way they write that there. That's not a big deal. The big thing is a constant value of x is vertical line. Constant value, whenever there's a constant value of x and you're graphing a constant value of x in 2 dimensions, a constant value of x means vertical line. A constant value of y in 2 dimensions is a horizontal line. Okay. If the line slopes upward to the right, positive slope. It slopes upward to the left, negative slope. A slope of 0, horizontal line. Constant y value. Constant x value means vertical line. Okay. In addition to that, what if somebody did this? Say, okay, Bayless, what if I had this guy as y is less than 3x plus 5? Kind of the inequalities that we were talking about last time. If that was the case, all values of y would be less than this. So it'd be all of this. It'd be these values downward. Everything downward, and they would break this thing up. Like this, like this, like this, like this. The line's got to be dashed. If it's less than or equal to, then it's a solid line. Then it's a solid line. What if it was the other way around? Y is greater than or equal to 3x plus 5. It'd be the same exact thing, same exact graph. I didn't draw this too well, guys, and it'd be this, everything going up. And you'll see that in there. You'll see that stuff in there. It'd be everything going up. So that's what's going on there. Not bad, not bad. I think we're doing okay. Let me do one last problem. It was similar to the one we did last time on this. And this will take us to a large extent, I think, through that practice test that they had developed a long time ago. Practice test number 1, old practice test number 1. But so what if it's an old practice test, number one? The content is the content. The algebra is the algebra. If you know this stuff, you're going to know this course. After I'm done with all 4 of these practice tests, you're going to know anywhere from 95 to maybe 100% of everything you need to know, or at least real close to it. 95 to 99% of what you need to know you're going to have in those basic practice tests if you know how to do it. Okay. We do one last problem here. We'll call it a day on this one. And then I'll go into exam number 3. I'll go into exam number 2, practice exam number 2 the next time that we get together. It's going to look really similar to what we did, guys. So I'm going to fly through it a little bit, get it done there for you. At least you'll have it. You'll have it on record there, so it shouldn't be that bad for you. It's not like you're doing. That's the one advantage this has to doing something live sometimes. You at least got it on tape, so you can kind of look at it. So what's the one I saw that I liked? Number 58, it says, find an equation of a line satisfying the conditions. The line goes through a particular point, -7, -6, and it's perpendicular to 4x plus 7y equals 61. Find it. Okay, it's going to go fast, guys. Let me get it done for you. Let's get it done for sure. They want you to find the line that passes through -7, -6. That's x comma y. This could be any x comma y, but for this particular x comma y, under consideration, you got this. You want to find the line that passes through that point. Well, I got news for you. The x value is -7. The y value is -6. The x value is -7, the y value is -6. It'd be nice if I knew how to write x and y. Sorry about that. The x value is -7, the y value is -6 for this situation. I want it passing through this point. I got news for you. There's an infinite number of points. There's an infinite number of points that pass through, forgive me, there's an infinite number of lines that pass through that point. Yeah, true. There's an infinite number of lines that pass through that point. I want, of those infinite number of lines that pass through that point, I want specifically the line that is perpendicular to this line and passes through that point. I want the line perpendicular to this line. I want it to be, passes through here. And again, look at the thing I gave you online so that you can read what I'm doing. Passes through that guy and perpendicular to that guy. I want them perpendicular to him. Okay, well, I'll tell you what I'm going to do. That's an equation of a line in general form. I'm going to write it in slope-intercept form. I'm going to write it like this. And then I'm going to make the moves. I'm going to write it like that. How am I going to do that? Well, I'll solve for y. Let me leave 7y alone, and let me add a -4x. Let me add a -4x on each side. All right, I added a -4x on each side. Let me divide by 7 on each side. Let me divide by 7 on each side. Make sure I'm doing this right, guys. Yeah, it looks pretty good. Let me divide by 7 on each side, and you can divide all the way across by 7. Okay, that ain't a big deal. That is the slope, not the x, the thing in front of the x. That's the slope. So what line, that's the slope. Give me a line, what's the slope of a line perpendicular? What's the slope of a line perpendicular to this line? Its slope has to be the negative reciprocal of this. The negative reciprocal of this is flip it upside down and throw a negative 1 in front of it. What's negative 7 over 4? What's negative of negative 7 over 4? It's positive 7/4. Is that true? Is it true if I take these two guys, multiply them together, I get negative 1? If I take negative 4 over 7 and multiply it by positive 7 over 4, sure as anything, it works. The 7 over 4 is the slope of the line that is perpendicular to this line. This line's got to be converted to this. These two lines are the same line. Two lines are the same line. Perpendicular to him, you got it, right here. Therefore, it's going to be y equals mx plus b for the perpendicular line now. This is the big cheese. This is the one we're going to get. Y is y. M is. So y is y. The slope for the perpendicular line, I just delivered that speech, guys. You got it right in front of you. Just confirmation of it. This is the slope of the line, negative 4/7 of the original line. And the line that's going to be perpendicular to this line has the negative reciprocal of this slope as its slope. This is the slope of the line that's perpendicular. So you got this. Great. I just got to find b and I'm done. Sounds good to me. Let's put x equals negative 7, y equals negative 6. Y is negative 6. X is negative 7, so we can call it negative 7 over 1, or just negative 7. That don't matter much. Again, we said x is negative 7. X equals negative 7, y equals negative 6. Yeah, I'm just grinding this out, guys. Let me add that over here. Negative 6 plus, let me add a positive 49 over 4. Negative 6 is the same as negative 24 over 4. So B equals negative 24 over 4. Yeah, but negative 24 to negative 24. Negative 24 divided by 4 is negative 6. Here it is. What is this at the end of the day? At the end of the day, y equals 7/4 x plus 25/4. Y equals 7/4 x plus 25/4. Just confirm that on this. They might not have the same answer I got. I'm confident I have the right answer. Don't worry about it. Procedure at this point is going to be the paramount thing here. 58, right? Yeah. 58. For number 58, y equals 7/4 x plus 25/4. And that's the argument. That's how this whole thing proceeds, you guys. How are you going to do it? Procedures are good. And there you go. There you go. That's the lion's share. That's, there's other stuff here too. You're going to look at it. We're going to figure it out. But that's a lion's share of what I wanted you to know from old practice exam number 1. So I think it's going to help you out a lot in that regard. Okay. Let me get the gentleman to shut this off, and we'll take it from there. And I'll see you guys for the old practice exam number 2 the next time that we get together. Thank you very much for your time.